All right, guys, let's go ahead and take a look at this last problem here. It says a projectile is launched at an angle of 26 degrees and lands 8 seconds later at the same height that it was launched at. So if I were to draw a picture, here's my projectile. It's launched at a 26-degree angle, goes up, 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 reaches the apex, and comes back down and lands at the same height. The total time it takes to do that is 8 seconds. What is the initial velocity of the projectile? What is the initial x velocity as well? All that good stuff. So let's start by filling out our table down below. In order to do that, we need to assign our origin. So up is the positive y, and to the right is the positive x. So some information I have here, well, it starts at 0x, and it starts at 0y. It ends at 0y. The acceleration of the y is negative 9.8, and the acceleration of the x is 0. The total time it takes is 8 seconds. And that's all the information I have actually to begin. So I don't have a lot of variables on the x side, but I have a lot on the y, so I can go ahead and start on the y side. On the y, I can start by figuring out what VO is or what VF is. If I look at my equations, there's two ways I can do this. One is I can use big dog to solve for VO, or the second one is that I can actually split this problem in half and solve at the apex. I'll go the easier route, or actually I guess it's the harder route, and just use big dog to solve for it. So big dog is df equals do plus vot plus 1/2 at squared. So I need to solve for vo here, so let me cancel out whatever's 0. This is 0, this is 0. I'm going to manipulate the variables first and then plug in my numbers. So I'll go ahead and subtract vo to the other side, so negative vo times t is equal to 1/2 at squared. I got to get VO by itself, so I'm going to divide by negative t. Therefore, I find out that the initial velocity in the y direction should be equal to 1 at negative. So negative 1 at over 2, okay? Because it's 1/2 at squared, so 1/2 at. The t squared cancels out with the t, but you're left with the negative there. So if I do all this, I can plug my numbers in here. So I get negative 1 times negative 9.8 times t, which is 8, all divided by 2. Plug all that into my calculator, and I solve for the initial velocity in the y. And that's going to give me 39.2. Cool. After I have the initial velocity in the y, I know the final because it's just opposite. It points down. But I still need to figure out what the initial velocity is in the x. So this question is a little different than the ones that we've done before, because usually we still have some variables to go off of. We're going to solve for the x velocity not by using kinematics, but by using trig. So if I go up to my triangle, I can go ahead and label my y velocity. It's this side right here, 39.2. Since I have that, I can actually use trig to figure out what my x velocity is here. So let me take this triangle and expand it down below so we can see what I'm talking about. So here's my triangle. The angle, if I remember, is 26 degrees. So I'd write 26 degrees here. The y velocity that we just solved for is 39.2, and the x is unknown. So I need an equation that has the opposite side of my triangle, because this is the opposite, and an equation that has the adjacent. If I look up above, that's going to be tangent. So I have tangent of my angle, which is 26 degrees, is equal to opposite, which would be 39.2, divided by adjacent, which is velocity in the x direction. Got to get that by itself, so I'm going to multiply Vx over. So I get Vx times tan 36, and by 36 I meant 26, is equal to 39.2. Well, Vx isn't by itself. I need to divide by tan now. So Vx is equal to 39.2 divided by tangent 26. Now I've solved for Vx. I find out that Vx should be 80.37. And once I know VOX, I actually know VFX because it doesn't change. That's also 80.37. So let's go ahead and add this information to my table above. 39.2 and 80.37. Next question says, what's the total velocity in the angle? Well, the angle's already given to me. It's 26. I'm going to write that. But the total velocity I got to figure out. So I know what the x is. I just solved for it. It was 80.37. So to figure out the total up here, I'm going to have to use Pythagorean theorem. So the total is going to be equal to the square root of a squared, which is 80.37 squared, plus b squared, which is 39.2 squared. Go ahead and plug that into my calculator, and I find out that the total velocity should be 89.42. Next question says, how long does it take to reach the apex? If it takes 8 seconds to go the whole way, to reach the apex, it's only 4 seconds, so half the time. And then lastly, what is the maximum height achieved by the projectile? Well, we've done this already, so let's just do it one last time. To figure out the maximum height, I'm going to need to use big dog. Big dog is df equals do plus vot plus 1/2 at squared. Again, the v is my y, and vy we said was, let's just double check, is 39.2. And then time, well, this is the time at the apex, so it's only 4 seconds. So I have df is equal to, do is just 0, vo is 39.2 times 4, plus 1/2 times negative 9.8 times 4 squared, which I'll write 4 squared here. So if I plug all this into my calculator in parentheses and everything, I find out that the maximum height achieved should be 78.4 meters. And that's it for this problem.